Hi everyone. Okay, so as promised, I said that I would make a video of what I talked about today. I know a few of you missed class, so this is what it is. This is what I talked about in class today, in a nutshell, but it will still be thorough enough that you should be able to pick it up. Okay, so what I was questioning at the beginning of class was, what did everybody remember? We remembered that average velocity is nothing different than average rate of change. We learned that that's equal to the slope of a secant line that connects two endpoints of an interval, okay? And we can write that as f of a plus h minus f of a over h, and that's called the difference quotient, okay? Then we learned that the instantaneous velocity, or instantaneous rate of change, is equal to the slope of a tangent line, and that is the limit as the interval width between the 2 points get really, really close, a teeny tiny little secant line approaching the slope of a tangent line, is the limit of that difference quotient. And that's denoted the first derivative, so that this is called f prime. This means the first derivative of the function f with respect to the point where x is equal to a. Alright, so remember when I'm going to do something simple with x squared. So f of x equals x squared. And I know what that function looks like. It looks like that. Okay? And I might be interested in knowing what is the derivative at the point. I think I used a 3 during class, but it doesn't matter. I might be interested in knowing what is the rate of change of this function at exactly the moment when x is equal to 3. In other words, what is the slope of a little tangent line to this function at the point where x is equal to 3? So what I know is that a is 3 in this case. Okay? So what I can write is the limit as h approaches 0 of f of 3 plus h minus f of 3 all over h. Right? And so in order for me to fill in the pieces of this formula, this is the formula you have to use right here. And what you want to do is you want to take the function that's given and you want to evaluate it, in this case, at 3 plus h, or whatever your a is, and then you want to evaluate it at f of 3. So I'm going to use different colors to kind of show you. So f of 3 plus h means take this thing and plug it into the original function for every x. So that's going to be equal to 3 plus h, the quantity squared. And if I expand this out or FOIL it, I'm going to have 9 plus 6h plus h squared. Okay? If I substitute in, if I want to figure out what f of 3 is, well, now I just need to take this 3 and plug it into the function for every x I see. Well, we have 3 squared, which is 9. So the idea is that you're going to rewrite this as the limit, as h approaches 0, of f of 3 plus h. Actually, let me do this. There's a minus in the formula, right? So this is in the formula, this is in the formula, the minus is in the formula. All I'm going to do is replace this with this, so 9 plus 6h plus h squared, minus, and I'm going to replace this with 9. Okay? And what you notice, very nicely by the way, is that the 9's are going to cancel. So we can rewrite this as the limit, as h approaches 0, of 6h plus h squared all over h. And the idea here is, if I plug this 0 in for h, so with a limit, what we're going to do is we're going to simplify this expression as much as we can, and when we cannot express or simplify it anymore, we're going to substitute the 0 in for every h. So if at this point it's unsimplified, if I plug this 0 in, I'm going to have 0 over 0, and that's bad, because I can't divide by 0. So we have a big problem. So the whole idea of this is that you factor out an h in the numerator so you can cancel it with that h in the denominator. So we write the limit as h approaches 0 of h times 6 plus h, that's factoring it out over h, and then you can see the h's cancel. Now what I'm left with, and you notice I keep writing this limit, you have to keep writing it for every single step until you actually take the limit. So what I'm left with is this. I can't simplify this expression anymore, so now it's time to take the limit. And when we take the limit, it's just a matter of plugging 0 in for h. So this is going to be 6 plus 0, or 6. So the first derivative, or the slope of the tangent line, of this function x squared at the point where x is equal to 3 is roughly 6. Hang on one second because I forgot my bag and I did calculator work, so I want to grab my calculator. I'm back. Sorry about that. I completely forgot about it. Now, I showed the class that your calculator can actually do this work for you. So all you have to do is put your function into y equals. So I'm putting it in y1, and the function was x squared. And then hit the graph key. Now my window's off because I was doing some things, so just do zoom 6. And there's your parabola, okay? Now, we were interested in finding the tangent line, or the derivative, at the point where x is equal to 3. And so all you have to do is press second program, which is the draw program, and scroll down until you see tangent. So mine's at number 5, so I'm going to press 5. Now don't press enter, because at this point the calculator needs to know what point along this curve do you want the derivative at. Well, we want it at 3. So I'm pressing 3, then hit enter. And when you do that, it'll draw the tangent line. It'll give you, let me see if I can bring this a little bit closer. Whoa. Sorry. Let me do this. It'll give you, at x equals to 3, the equation of the tangent line. It's going to be a linear function because it's a line. And guess what? The derivative, or the slope of that tangent line, is 6. Pretty cool stuff. Now to clear that line off, because if I hit y equals and, you know, maybe I want to know something about x cubed. Oops. X cubed. What's going to happen is the cubic's going to draw, oh, it didn't on this one. Alright, on some calculators the line will not go away, that tangent line, so to get rid of it, you just press second draw key again, second program key, and number 1 is clear draw. If you press 1, it'll get rid of the tangent line if it won't go away on its own like mine just did. I didn't know my calculator did that. I remember my other one, I had to use clear draw. Okay? So let's look at another one. So how about f of x equals 2x squared plus 3x minus 5. And we want to find the value of the derivative when x is equal to 1. So the first thing I have to do is find the derivative of this thing. And, well, sorry, no I don't. So my a is 1. So I'm going to have the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h. Now over to the side, you know, I'm going to compute f of 1 plus h. Well, this equation is bigger, so that means it's going to become more nightmarish. Well, that's equal to 2 times 1 plus h squared plus 3 times 1 plus h minus 5. In other words, I have to plug this in for every x I see in my function. And if I expand this out, this is 2 times 1 plus 2h plus h squared. So I'm just doing this very quick. I know you guys can FOIL. If I distribute this, I'm going to have plus 3h minus 5. And now I'm going to distribute that too. So we're going to have 2 plus 4h plus 2h squared I'm going to combine the 3 and the negative 5, so plus 3h minus 2. And now I'm going to combine like terms to try and simplify this. So the 2's are going to cancel, so that's nice. So I'm going to end up with 4h plus 2, 4 and 3 is 7. 7h plus 2h squared. Hi, puppy. Sorry, my dog just came in. That's what I'm going to replace this piece with. This is going to go in here. Now f of 1, that's easy. That's just 2 times 1 squared plus 3 times 1 minus 5. That's 2 plus 3 minus 5. It's 0. So, I'm going to replace this with this. So we have the limit, as h approaches 0, of 7h plus 2h squared minus 0 over h. That's equal to the limit. Now I'm going to factor out an h. So that way I can cancel those. And that's the limit as h approaches 0 of 7 plus 2h. And I can't simplify it anymore, so I'm going to take my limit. And so what we get is a 7. Now let's see. Clear this out. I have 2x squared plus 3x minus 5. I'm going to hit the graph key. And I'm going to do second. So second, draw 5 at x is equal to 1. Hit enter. And don't know if you can see that, but there it is. The slope is 7. And the equation's there. Okay, so you can double check with your calculator if you have to do one of these. The other thing is when we're evaluating this at a point, at some x equals to a, you're going to end up with a number as a result. So in this one we ended up with a number, and the one above we ended up with a number. So then I said, what if I did this? Now I'm not evaluating at any particular point. I'm going to evaluate over the entire domain of the function. So let's stick with x squared for a second. Okay, so again, this is nice and smooth, and so there, for every single point on this curve, I can find the derivative. Why it wants to go out of focus. Okay, so now instead of rewriting this with 1 plus h or f of 1, now I've got to evaluate for this piece here, what is this function f, which is x squared, evaluated at x plus h? Well, that's just x plus h squared. And if I expand that, I'm going to have x squared plus 2xh plus h squared. And if I look at the right-hand side, I have to substitute in f of x. Well, what's f of x? It's the function itself. So I know f of x is x squared. So using the same idea, I'm going to say the limit as h approaches 0. Now, again, this minus sign is fixed and that h is fixed. On the left side of the minus sign, I'm going to replace this with what f of x plus h is, which is x squared plus 2xh plus h squared. And on the right, I'm going to replace f of x with what f of x is, which is x squared. And you see that those x squared terms are going to cancel in the numerator, so we have the limit as h approaches 0 of 2xh plus h squared over h. And the idea is the same. We want to factor out an h in the numerator so we can get rid of it with what's in the denominator. So if I factor out an h, I'm left with 2x plus h in the numerator over h. The h's cancel, and now I'm at that point where I cannot simplify this anymore, so I can take the limit. When I take the limit, that means I plug this 0 in for every h I see, and in this case, there's only one h, so 2x plus 0 is just 2x. So when it's in this form, you get the derivative function. If you're plugging in a number for a, like 1 or 3 or whatever, you're going to get a number. You're going to get a value. But here we get an entirely new function. So I can say f prime of x is equal to 2x. The derivative of this function, x squared, is 2x. Here's another one. Well, why don't we use that other one there that we did in the last example. If f of x is 2x squared plus 3x minus 5, find f prime of x. Okay, so limit as h approaches 0, f of x plus h minus f of x over h is equal to the limit as h approaches 0 of some stuff, right? Well, what's f of x plus h? It's 2 times x plus h squared plus 3 times x plus h minus 5. That's going to be 2 times x squared plus 2xh plus h squared plus 3x plus 3h minus 5. And distributing, we're going to have 2x squared plus 4xh plus 2h squared. And now I can combine like terms if there's something there for me to combine, and there's not. So, in this thing here, this whole giant thing, and I'm going to rewrite this because I don't have enough room, it's going to go on the left-hand side. On the right-hand side, what goes in? F of x. What's f of x? F of x is the function itself. So this is going to go on the right-hand side of the minus sign. So we have the limit as h approaches 0 of 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 5 minus, okay, so that's this here. Remember, if you have more than one term to the right of the minus sign, use parentheses so you don't forget to distribute. So the function itself, f of x, was 2x squared plus 3x minus 5. And now I have to make sure I don't forget to distribute this sign to every term here. So we have the limit as h approaches 0, 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 5 minus 2x squared minus 3x plus 5 all over h. What you're going to notice is that, well, I'll do it here. These two are going to cancel, those two terms are going to cancel, and those two terms are going to cancel. So now you can write it a little more compactly. And at this point I'm going to factor out the h in the numerator, so that way I can cancel it with the h in the denominator. And now I'm at the point where I cannot simplify this expression anymore, and so I'm going to take the limit, and the limit means you plug in the 0 for every h you see, and if I do that, 2 times 0, that term's going to go away, so I'm left with 4x plus 3. So this is the derivative of that function. So there is no value, I'm checking all values, so I get a new function. In the other case, I got a number. Capiche? So that's all I talked about today, and the kids did a bunch of practice problems, and you're going to do some practice too. The other thing I mentioned though, let me just say this, I'm just going to use this function here. So the absolute value of x, if I graph that, you know it's got a corner at x equals to 0, right? And what you need to remember is that the derivative exists for every point from negative infinity all the way to 0, and it exists for every point from 0 not included to infinity. But at the point x equals 0, because there's a corner, the derivative is not going to exist there. So they call it a cusp or a corner. The derivative does not exist. And that's it. That's all I talked about in class. I hope this helps. Do the homework, which is posted on ESB, to get some practice in. And if you have any questions, I'll answer them on Wednesday morning. Have a great night.